resins, etc. Okay, so our next topic is polymerization process. How can we carry out polymerization? There was a scientist named W.H. Carothers who proposed two mechanisms for polymerization. One was addition and the second one condensation polymerization. There are three steps in addition polymerization: initiation, propagation, and termination. This addition polymerization is basically free radical mechanism. Free radical mechanisms are the one which use free radical in it. How can we generate this free radical? What we do is, in initiation process, we provide the molecule. Okay, this molecule is basically organic peroxide. What are peroxides? Peroxides are the species which have this group in them, this functional group, OO. Any species which has this functional group is known as peroxide. This is organic peroxide. When we heat this molecule, either by the use of sunlight or either by artificially, what happens that this molecule cleaves down. How does it cleave? Look this point. These oxygens are connected to each other through a bond, single bond, and you know all that this bond is formed of two electrons. Every bond is formed of two electrons, right? One from this oxygen and the other one from this oxygen. When we heat this molecule, it cleaves. It goes homolytic cleavage. Cleavage means it is broken down. Okay, the molecules broke down into two pieces. It will be broken down at this position, at this side. When we break down this molecule, one electron will be shifted to this carbon and the second electron will be shifted to this oxygen and the second over this oxygen. So we'll have two structures of R C double bond O O. Again one structure and second R C double bond O. So we get two R C double bond O structures and each one of them has odd number of electrons. See, this oxygen has one electron and this oxygen has one electron. We show this one electron or the odd electron by a dot, right? So this whole molecule is a free radical, but we cannot use such a large free radical in our procedures, in our processes. So what we do is that we have to break it down further. When we heat it further, it will break down at this site. This RC bond will be broken down. Okay, what will happen? One electron will be shifted to carbon and the second electron will be shifted to hydrogen. Now this oxygen had one electron and this carbon has one electron. This one electron of carbon and this one electron of oxygen will join to form a bond and this bond will become double. So look over here. C double bond O, C double bond O. This is the structure of carbon dioxide, which is C double bond O, C double bond O. So we had separated carbon dioxide, we have removed carbon dioxide from the structure and we are left with R. R has one odd electron which we show with the presence of this dot. Okay, what happened? We heated this molecule and it was broken down into two pieces. One was carbon dioxide molecule and the other was R molecule or R free radical. But we had two molecules of this huge structure. So we'll get two molecules of carbon dioxide and two free radical R. Now our initiation process is completed, in which we have generated our required free radical. Now we will use this free radical in our next process, which is known as propagation. Okay, actually we are carrying out the polymerization of styrene. What we'll do, this is a styrene molecule. We'll attach free radical with this styrene molecule. This free radical R will attack on this carbon. Okay, we'll join R CH2. But look over here, it had double bond and the bond has become single. Why is it so? Because you all know the valency of carbon is 4. Carbon can make 4 bonds at a time. This carbon is making 2 bonds with hydrogen and 2 bonds with carbon, so total 4 bonds. But if we join this carbon with R, the bonds of this carbon will become 5. So to maintain 4 bonds of this carbon, we have to single this bond. This was a double bond. If we convert it into a single bond, the valency of this carbon will be satisfied. All right. So that this are mixed bond with this carbon, but this one, this bond becomes single. This carbon again count the bonds. 2 bonds with hydrogen, 1 bond with the carbon, 1 bond with the R. So it has 4 bonds. Valency is complete. But the problem is over here. This carbon is making 1 bond with this carbon, 1, second bond with this carbon, 2, and third bond with the hydrogen. It has 3 number of bonds. So it has odd number of electrons which are present over here, which are shown with the help of a dot. If this carbon gets one more free radical, the bond will be created and the valency will be completed. Coming to the next step, this free radical will attack on the second styrene molecule. This C will make bond with this carbon and this double bond will again be singled. Okay, or CH2 CH C6H5, this molecule, this is joined with styrene CH2, bond becomes single, CH6H5. Again this carbon is making 3 bonds, one with this carbon, second with this carbon, and third with hydrogen. So its valency is not complete, so we will show this with free radical over here. Moving to the third step, this free radical will attack on the third styrene molecule. This free radical will attack on this carbon, and again look at this position. CH C6H5, this is connected with CH2, which is further connected with CH C6H5. Again this carbon has 3 bonds, so the left out valency is shown with the help of a dot, so it is a free radical, and this process will continue until and unless we get our desired polymer. For example, if we want to join 50 monomers of polystyrene, we'll carry out this process to 50 steps. But once we are completed with our polymerization, we are done with our monomer joining, we will go to the last step, which is termination. In termination process, look over here, R, CH2, CH, C6H5, N is the number of these styrene molecules we have joined. For example, in this process we have joined 3 styrene, so we'll substitute this N by 3. Now look over here, we had 2 R free radicals. One is used in the propagation and process, and the second one is used in the termination process. This free radical carbon will be joined by this free radical R, and the whole molecule will become neutral. So the purpose of termination is the neutrality of the molecule. We join 2 free radicals and our molecule becomes neutral overall. The second category or the second polymerization process is condensation polymerization. Condensation is any process in which we join 2 molecules, but there is a release of small molecule like water, ammonia, methanol, etc. We join 2 large molecules and a small molecule is eliminated in this process. So this process is known as condensation process. Look over here in this example, I have taken dicarboxylic acid. Carboxylic acid is the one which has C double bond O OH group. This. Any molecule which has this group in it will be known as carboxylic acid. As it has 2 carboxylic group, we'll call it dicarboxylic acid. Similarly, come over here. CH2, CH2, OH, OH. This is a diol. What is it? Diol. Alcohol is any species which has OH group in it, but this compound or this molecule of ours has 2 OH groups, so we'll call it diol. So we have joined 2 molecules, one is dicarboxylic acid and the other one is diol. Now look over here, OH of dicarboxylic acid and H of alcohol or diol combine to form water, right? So water is released, so we'll be creating a bond C double bond O. Look over here, this is same. C double bond O, OH has gone, H is gone. We are left with oxygen, then CH2, CH2 again, O. This O is further connected to diol, and this end is further connected to this end is connected to dicarboxylic acid, and this end is connected to diol, and we have released water molecule. So this process is known as condensation polymerization, in which we join two molecules and there is a release of a small molecule like water.